Work out the amount of chicken stock he needs. Well, in order to convert the ingredients list from a leek and potato soup for 6 people to 13 people, if I divide each amount by 6 and then times by 13, it'll tell me how much I need for 13 people. We want to calculate the amount of chicken stock that he needs. So 900 divided by 6 times 13, 1,950 milliliters. Delia makes leek and potato soup for a group of people. She uses 1,250 grams of leeks. Work out the number of people in the group. Well, the recipe says that for 6 people we need 750 grams of leeks. So using a similar equation to before, 750 grams divided by 6, so that's the amount needed for one person, times by A, the number of people Delia is cooking for, equals 1,250. Reversing this process, so timesing by 6 on both sides gives me 750 times A equals 7,500, and then dividing by 750 gives me a value for A, which equals 10 people. Work out the distance the plane flew. Well, distance equals speed times time. The speed, 852 kilometers per hour. The time, 10.75 hours. 45 minutes is 3/4 of an hour. 3/4 is a decimal, 0.75, so it's 10.75 hours. 852 times 10.75 is 9,159 kilometers. Calculating the value of x, well, we've got a right-angled triangle, 2 sides in an angle, so we're thinking SOHCAHTOA, labelling the sides opposite, adjacent, longest side, hypotenuse. We want to find the opposite, we know the hypotenuse, so sine theta is opposite over hypotenuse. Now I want to find the opposite using my formula triangle. Opposite equals sine theta times hypotenuse. So therefore x equals sine 43 times the hypotenuse 7.8. This gives me a value of x of 5.32 to 3 significant figures. Write 2 cubed times 2 to the power of 4 is a single power of 2. While I'm multiplying, I add my powers. So 2 to the power of 3 plus 4, which is 2 to the power of 7. 280 equals 2 to the power of n times 5 times 7. Well, if I reverse that process and say divide by 5 on both sides, leaving me with 56 equals 2 to the n times 7. Again, opposite of times 7, divide by 7. So 8 equals 2 to the power of n. Trying different values of n, and you'll find that 2 to the power of 3 equals 8. So therefore n equals 3. Question 5. Simplify. Well, 5 times 4, 20. C times c, c squared. Factorise, looking for a common factor. X times 4 gives me 4x. X times x gives me x squared. So factorised, x brackets 4 plus x. Work out the value of y cubed plus 5y when y equals 2. When I substitute in where I see a y, I sub in a 2. So 2 cubed plus 5 times 2. 2 cubed is 8. 5 times 2 is 10, therefore 18. We know from circle theorems that the angle between a radius and a tangent is always 90 degrees. Equally, the angle TOP, this one here, is alternate to the angle OTQ, alternate or Z angle, so therefore this angle here is 58 degrees. 180 degrees in a triangle, 180 minus 90 minus 58 equals 32. Looking at this number line, we want values greater than -1 but less than 4. Equally, the difference between the dots, so a hollow dot means not equal to, a filled in dot means equal to. So we want our values, let's say x greater than -1, less than or equal to 4. Part B, solve the inequality. Well, if I multiply out 2y minus 6 greater than or equal to 1, add 6 to both sides, so we get 2y greater than or equal to 7, and then divide by 2. So therefore y greater than or equal to 3.5. Part 2, write down the lowest integer that satisfies this inequality. So the lowest integer is whole number, so we want the smallest whole number that is greater than or equal to 3.5, and that's going to be the number 4. 4 is the smallest whole number that is greater than or equal to 3.5. Work out the percentage of the 80 tea bags that weigh more than 3.1 grams. Well, the tea bags that weigh more than 3.1 are these ones here. So we've got 32 plus 14 plus 6 out of a total of 80. We want it rather than a fraction as a percentage. So if I multiply by 100, and that gives me the solution 65%. Part B, work out an estimate for the total weight of the 80 tea bags. Use halfway values of 2.85 grams, 2.95 grams, etc. Well, yeah, we don't know the weight of the 2 tea bags that are in the first group, so we estimate midpoint 2.85. The midpoint of the second group 2.95, third group 3.05, etc. Now we have 2 tea bags that we've estimated weigh 2.85 grams. So in total, 2 times 2.85, 4 times 2.95, etc. And then sum that amount gives us the total weight of the 80 tea bags. Summing all those values gives me 251, which is the total weight of the 80 tea bags. Using the graph to estimate the number of tea bags which weighed more than 3.25 grams, if I go to 3.25 and then across on the axes, obviously you can do this slightly more carefully than I have using a ruler, you should get approximately 69 tea bags. 69 out of a possible 80, so therefore 80 minus 69, leaving me with a total of 11 tea bags that are greater than 3.25 grams. Using the graph to find an estimate for the interquartile range, well, we've got a total of 80 tea bags, so the median would be at 40 tea bags, the midway point. Therefore the lower quartile, half of the median value, or where to look for the median value, and upper quartile, 3/4 of the total frequency, or median plus where you look for the lower quartile. So hence our lower quartile is going to be 3.07. Each small box is 0.01 grams, and upper quartile 3.2. Therefore, the interquartile range will be 3.2 minus 3.07, which equals 0.13. That is the interquartile range in part D of this question. The single transformation which maps triangle P onto Q, say from the small to the big, is an enlargement. 1 mark. Scale factor, well, if you look at one of the sides of triangle P, so the bottom one has width 2, goes to width 3, so therefore the scale factor is 3, it's 3 times bigger. And we now find the centre of enlargement. So if you draw lines connecting the vertices of the triangles, the lines will cross at the centre of enlargement. You can obviously do this far more accurately than I can using a ruler, but you'll find that they all cross at the coordinate point 4, 3. Therefore the centre of enlargement is at the coordinate point 4, 3. Translate triangle Q by the vector minus 8, 2. Top number tells us our movement left or right, negative left, so we're going 8 left. Bottom number, positive up, negative down, say 2 up. So we need to move every point on triangle Q 8 left and 2 up. You can then label this new triangle as triangle R. Obviously use a ruler when you do this. Mapping triangle R onto triangle P is still going to be an enlargement. This time we're going from big to small, so scale factor, gone from side, bottom length 3 to bottom length 1, so scale factor 1/3. Equally again we need to find the centre of enlargement. So by the same method as before, connecting the corners, you find the centre of enlargement to be the point 8, 2. So that's an enlargement by scale factor 1/3 with the centre 8, 2. Serena bought a car that had a value of $16,000. At the end of each year, the value of her car depreciated, that means decreases, by 15%. 100% minus 15%, because it's a decrease, is 85%. So after the first year, the value of the car will be 85% of the original amount that she bought it for. So if I was to do 16,000 times 85%, that would be the amount after the first year. Timesing then that amount by 85% again, and 85% again, would give me the amount at the end of the third year. An alternative way of doing that is just to raise it to the power of 3. 3 being the number of years after having bought the car. 16,000 times 85% to the power of 3 gives you a value of $9,826. Remember, when putting this into the calculator, you must include the percentage sign. Alternatively, you could do 16,000 times 0.85 to the power of 3. 85%, 0.85, equivalent to one another. When adding or subtracting fractions, you need to have a common denominator. Here the common denominator would be 4. Obviously I therefore need to multiply the second fraction, top and bottom, by 2. Timesing the top of the second fraction by 2, 5 times 2, 10, 2 times minus 2x, minus 4x. I can now subtract the fractions, so I've got 6x minus 1 minus the numerator, so minus 10 minus 4x plus 4x all over 4 equals 1. If I now multiply both sides by 4 to cancel out the denominator of the fraction, and then simplify the left-hand side of the equation. So I've got 6x plus 4x, 10x, minus 1 minus 10, minus 11, and the right-hand side 1 times 4, which is 4. So 10x, to get rid of the minus 11, plus 11 on both sides. So 10x equals 15. Therefore, x equals, divide by 10. Divide by 10, 1.5. In order to work out the area of the total shape, we need to work out the area of the triangle and the area of the semicircle. In order to work out the area of the triangle, half base times height, I need to work out the height, BC. Pythagoras' theorem tells me that in a right-angled triangle, a squared, being the hypotenuse, equals b squared plus c squared. So 9.5 squared equals 7.6 squared plus bc squared. Therefore, 9.5 squared minus 7.6 squared equals bc squared. To get rid of the plus 7.6 squared, I need to minus it from both sides. Hence, square root 9.5 squared minus 7.6 squared equals BC. So BC equals 5.7 centimetres. So the height of the triangle is 5.7 centimetres, and the radius of the circle, well, that would be 5.7 divided by 2. BC is the diameter, so if I divide it by 2, I'd get the radius, which is 2.85. I now have all the information I need in order to work out the area of the triangle and also the area of the semicircle. So first off, the area of the triangle, half times the base, 7.6, times the height, which is 5.7. Perpendicular height, not diagonal height. So that's the area of the triangle. I need to then add on the area of the semicircle. The semicircle is half of a full circle. Area of a full circle, pi r squared. So a half, or pi, times my radius squared. Putting that value into your calculator, and you should get the solution 34.4 centimetres squared to 3 significant figures. So that's 34.4 centimetres squared. Calculate the probability that the two nails she takes each have a length of 60 millimeters. Well, on the first pick, the probability of picking a nail that has a length of 60 millimeters, well, there are 2 nails out of 20 nails. So probability 2 out of 20. And, which in probability is multiply, picking another 60 millimeter nail. Note that she takes at random one of the nails and records its length, and she replaces the nail back in the bag. So therefore there are still 20 nails in the bag after she's taken the first one, because she replaces it. 2 times 2 is 4, all over 20 times 20 is 400, or simplified, 1 over 100, or 0.01. Have a total length of 80 millimeters. Well, in order to have an exact total length of 80 millimeters, she must either pick a 40 and then another 40 millimeter nail, or a 30 and then a 50, or a 50 and then a 30 millimeter nail. Probability of picking a 40 millimeter nail is 4 out of 20, and in probability we said was times, again 4 out of 20, or probability is add and times. Picking a 30 millimeter nail, the probability is 8 out of 20, and a 50 millimeter nail, that is 5 out of 20, or a 50 millimeter nail and a 30 millimeter nail. Multiplying and adding on the calculator leaves you a solution of 6 over 25, or 0.24. So 6 over 25 or 0.24. D is directly proportional to t squared. Alternatively, we can write this as d equals k t squared, where k is a constant that we need to find. We know that when d is 8, t equals 4. 4 squared, 16. So we've got 8 equals 16k. Now in order to find my k value, divide by 16 both sides. So therefore k equals 8 over 16, or a half. The question asks to find the formula for d in terms of t. So our solution is not k equals a half, but d equals a half t squared. So that's subbing my k value back into the original equation we formed. Find the positive value of t when d equals 50. So substituting into the equation that we have just generated, 50 equals a half t squared. To get rid of the half, if I times by 2 on both sides, giving me 100 equals t squared. Opposite of a square, square root. Square rooting 100 gives me plus or minus 10. The question, find the positive value of t when d equals 50. So t equals 10, not negative 10. To calculate the area of the parallelogram, if I was to cut off that triangle there and move it over here, I'd have a rectangle whose width 8.9 centimeters and whose height we can calculate using SOHCAHTOA. So considering this triangle on the far left, 6.7, the angle in this corner is going to be 90 minus 74, which gives me 16 degrees. If I want to calculate the height, so the height of the triangle, let's call it length x. See, labelling my sides, opposite, longest side hypotenuse, and this side must be the adjacent. I want to find the adjacent, I know the hypotenuse, cosine. So if I want to calculate the adjacent equals cosine theta times hypotenuse. So adjacent x equals cosine the angle 16 degrees times the hypotenuse 6.7. This gives me a value of x of 6.44. So therefore, to calculate the area of the parallelogram, which we've constructed into a rectangle, I need to do the base 8.9 times the height, either using 6.44 or actually let's use cosine 16 times 6.7, which gives you a value of 57.3 to 3 significant figures. So 57.3. Remember this kind of question, don't round early on. So if you've calculated the value of x to be 6.44, don't substitute 6.44 into the final equation, but use all of the numbers on the calculator screen. So it'd be 8.9 times 6.44, etc. All the values on the calculator screen. Alternatively, use cosine 16 times 6.7. In order to make y the subject of the formula, I need to get to the point where I have y equals with all of the y values on one side. So to get rid of the square root, if I square both sides, so y squared equals ay squared plus n. And now taking away ay squared from the right hand side, and so doing the same on the left hand side, leaving me with y squared minus ay squared on the left hand side and n on the right hand side. Then factorising, left hand side I've got common factor y squared, 1 minus a, y squared times 1 gives me y squared times minus a gives me the minus ay squared equals n. Now I'd need to divide by 1 minus a on both sides. Cancel, cancel. So y squared equals n over 1 minus a. Opposite of a square root. So y equals the square root of n over 1 minus a. So given that 5 minus root x all squared equals y minus 20 root 2, where x and y are positive integers, find the values of x and y. Well, if I start with the left hand side, so 5 minus root x all squared means I can write the brackets twice, and so then multiply out 5 times 5, 5 times minus root x, 5 times minus root x, minus root x times minus root x. That gives me 5 times 5, 25, minus 5 root x, minus 5 root x. Root x times root x gives me x. Negative times negative is also positive, so I've got plus x. Simplifying that, 25 minus 10 root x plus x. Now if I compare that with the right hand side, so y minus 20 root 2, then actually this term here, minus 10 root x, must be the same as the minus 20 root 2. So if I make them equal to one another, minus 10 root x equals minus 20 root 2. So therefore dividing both sides by minus 10, giving me root x equals minus 20 divided by minus 10, negatives will cancel, 20 divided by 10 gives me 2, so 2 root 2. Opposite of a square root is a square, so if I square both sides, 2 root 2 squared, so x equals 8. Once we found x equaling 8, well actually the other bits that we've got left in the equation is that the y must equal the bits left over. Okay, so y must equal 25 plus x. So y equals 25 plus 8, which equals 33. Finding the standard form expression for the square root of x, well, the square root of x will equal the square root of 9 times 10 to the power of 2m. Now, because underneath the square root sign, the two terms there, the 9 and the 10 to the power of 2m, are multiplied together, actually that means that I can break down my square root to the square root of 9 times the square root of 10 to the power of 2m. If that sign was a plus rather than a multiply, I wouldn't be able to do that step. Square root of 9 equals 3. Well, square root is the same as power half. So therefore, my rules of indices tell me that if I've got brackets, I multiply the powers, say 3 times 10, 2m times a half, just going to leave me with m, say 3 times 10 to the power of m. Part B, find the standard form and expression for y to the power of 3 over 2. Rather than writing it as y to the power of 3 over 2, I'm going to write it as y to the half, all cubed. Remember, our laws of indices say that I can, if I've got brackets, I can multiply the powers. Say 3 times a half, the same as 3 over 2. Therefore, with the right hand side, if I do the same thing, so put it to the power of a half, and to the power of 3. Well now, actually, if we compare with the previous question, 9 times 10 to the power of 2n to the power of a half, or a square root, gives me 3 times 10 to the power of n cubed. And I can now cube the parts in here, say 3 cubed, 3 times 3, 9 times 3 again, 27 times 10 to the power of n cubed. With brackets, I multiply the powers, so 10 to the power of 3n. 27 times 10 to the power of 3n. Factorise completely. Well, first things first, if I rewrite it, rather than a square, I rewrite it as a double bracket. And then multiply out the brackets, so 12 times 12x, 144x squared, 12x times minus y times 12x, minus y times minus y. So 12x times minus y gives me minus 12xy, minus y times 12x, minus 12xy, minus y times minus y, negative times negative is positive, y times y, y squared, so plus y squared. Take away, let's multiply out this bracket, 4x times 4x gives me 16x squared, 4x times minus 3y, minus 12xy, minus 3y times 4x, minus 12xy, minus 3y times minus 3y, minus 3 times minus 3 is 9, y times y, y squared. Note that I put that in brackets because it's take away all of that part there. So this simplifies to 144x squared minus 24xy plus y squared. Take away 16x squared minus 12xy gives me minus 24xy, but with the negative on the outside of the bracket, that will change the sign, so rather than being minus 24xy, it will be plus 24xy minus 9y squared. Simplifying this, well, you can see minus 24xy plus 24xy, and I've got 144x squared minus 16 squared equals 128x squared. So that's those two terms. and then I've got plus y squared minus 9y squared, so that's going to give me minus 8y squared. At this step, both parts divide by 8. So let's take out that common factor. 8 times 16 is 128, so 16x squared minus y squared. Now, the bracketed part is the difference of two squares. So actually my final solution is going to be 8, 4x at the front of both brackets, giving me my 16x squared plus y in one bracket minus y in the other bracket. 16x squared, I'd then get minus 4xy plus 4xy, which would cancel. Y times minus y gives me minus y squared. So therefore, fully factorized, 8, 4x plus y, 4x minus y. Minus 16. Find g f of x. Let me just note down f of x again. F of x equals 2x plus 5 from earlier on. So I'm replacing, this time, where I see an x in the function g of x with f of x. So my function g of x is going to become f of x squared minus 25. F of x we know is 2x plus 5. Take away 25. Expanding that bracket, 2x times 2x, 4x squared, 2x times 5 plus 10x, 2x times 5 plus 10x, 5 times 5, 25, and then obviously on the end, minus 25. So this gives me 4x squared plus 20x. Now, I want to leave it in its simplest form, so I need to take out a common factor and factorize. Common to both the numbers is a 4. I've also got an x common to both terms. 4x times x gives me 4x squared. 4x times 5 gives me 20x. So my final answer, 4x brackets x plus 5. Solving for where gf of x equals 0, so let's write down my function for gf of x. 4x times x plus 5 equal to 0. Well, either this term here has to equal 0, in which case 4x equals 0, so x must equal 0, or this term here must equal 0. X plus 5 equals 0, minus 5 from both sides, so x equals minus 5. So your solutions our x equals 0 and x equals minus 5. Find in terms of a and b, d to b. Now direction is important. I'm going from d to b. The route I'm going to take is actually via a. So therefore I'm going against the vector d to a. So d to b is going to equal minus 3b plus 12a. Part 2, d to e. Well, if d to e is a third d to b, then actually I've calculated already d to b. So d to e is going to equal a third of what I calculated d to b being minus 3b plus 12a. Multiplying that out, so d to e is going to be minus b plus 4a. A third of 3, 1, a third of 12, 4, so minus b plus 4a. A to e, so in order to go from a to e, the route I'm going to take, so starting there, a to d, d to e. A to d is 3b, d to e we've just worked out, so my answer is going to be 3b plus this one here, minus b plus 4a. So 3b minus b plus 4a, 3b minus b, 2b plus 4a. So the vector a to e equals 2b plus 4a. So for this part b, I need to first work out the vector b to c. So I'm going to go via a and d, so b to a, going against the direction, so minus 12a plus 3b plus 18a. 18 minus 12, so 6a plus 3b. So we've calculated that b to c is 6a plus 3b, a to e 4a plus 2b. What I'm going to do is I'm going to factorise these two vectors. Common factor in this one, 3, leaving me with 2a plus b. A to e, common factor is 2, leaving me with 2a plus b. Now in terms of the direction part is this bit here, which you can see is equal in both. What these 3 and the 2 tell you, they're scale factors. So they scale up how far you're going in that direction. Because the directions are the same, so b to c, its direction is 2a plus b, plus the scale factor 3. A to e, its direction is 2a plus b, plus the scale factor 2. So because the directions are the same, therefore they are parallel. Alternatively, to further demonstrate this, b to c divided by 3 equals 2a plus b. A to e divided by 2 equals 2a plus b. So therefore I can make them equal to one another because they both equal 2a plus b. So b to c all over 3 equals ae all over 2. So therefore b to c equals 3 ae all over 2, thus showing that actually they're in the same direction, they're parallel to one another. B to c is just 3 over 2 times bigger